رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقه قولي.
Assalamu alaikum dear students, how are you all? You all can call me Nabeela. First I would like to welcome you all to the 10th class of grade 6 maths lesson.
Can you identify what you can see from the slide that I'm showing you right now? That's right. You can see a thermometer, negative numbers, money, above and below sea level, right?
Let's check out the learning intentions and success criteria for today's lessons. Learning intention. Students will learn about integers, identify positive and negative integers, order set of integers, and compare two integers using symbols.
Success criteria. Students, you will be successful if you can tell positive and negative integers from the integers.
Order set of integers in ascending order or descending order. Compare two integers using the symbol. Okay, so before we move on with our lesson today, let's all watch a video.
We have seen what natural and whole numbers are. The whole numbers comprise of the entire set of natural numbers and 0. So what are integers then? Let's zoom in a bit. Along with whole numbers, the set of integers also includes negative numbers like -1, -2, -3 and so on. We have numbers like 1, 2, 3 and so on so that we can count. We also know why we have a 0. Now the question, why negative numbers? The most basic example would be temperature. The temperature can go below 0 degrees and the temperature below 0 degree is negative, like -10 degrees. Let us see a different example. Suppose you gave your friend 100 rupees and that friend returned just 50 rupees. What is the net amount you have now? The net amount you have is -50 rupees. We know there is no note available in the market which amounts to -50 rupees. But a negative sign tells us that you are in a loss. Coming back to integers, all these numbers are integers. We zoom out slightly to understand another interesting concept. The numbers 1, 2, 3, 4, 5 and so on are called positive integers, and numbers -1, -2, -3 and so on are called negative integers. We can also define natural numbers as positive integers. Then what about 0? Well, it's neither positive nor negative. Now look at all three of them together. It tells us that all natural numbers and whole numbers are integers.
Alright, let's move on with our topic for today. Let's just think. What exactly is an integer? Let me refresh your mind. An integer is a number that has no fractional part, no digits after the decimal point. An integer can be a positive number or negative number, or it can be a 0. Do you remember a number line? Let's look into the number line. I hope you all remember a number line, right? So, you remember, right? That's very good. So, now in this number line, you can see negative number, 0 and positive numbers, right? So, when you combine all these positive 1, 2, 3 down to the infinity and negative 1, 2, 3 down to negative infinity, including 0, the entire set of numbers give a special name in maths. Do you remember what the special name is? Yes, it's called integers. For example,
-9, negative 2, 0, 3.
Minus 2.3. Can this be an integer? Can this be? Yes, you are right. This is not an integer. This is a decimal. A decimal cannot be an integer. Alright now, let's think about some real life examples of negative and positive integers. I'll give you 5 seconds for you to think.
Very good. Now let's list out a few of them.
Below freezing point, below 0 for example, minus 11 degrees Celsius, below sea level. Let's look into the example. Let's say we want to use integers to measure how many meters above sea level small islands are. This island is 10 meters above sea level. This island is only 5 meters above sea level. And here you can see this island here happens to be exactly the same height as sea level. So we can use 0 to show how its height compared to sea level. Okay, now what about this one? It's not even above sea level, right? Let's say it's 5 meters below the sea level or below the surface. So how can we say that? Fortunately with the negative numbers that's not a problem, right? We can say its height compared to sea level is negative 5 meters, right? Therefore, we can say that negative numbers are very useful in the real world to help to describe things that can be above or below 0.
Do you know that the optimal temperatures in the freezer of a refrigerator is around negative 18 degrees Celsius, and that in the other compartments is around 4 degrees Celsius? It is because different foodstuffs require different temperatures to keep them fresh for a long time. Note that a positive number such as positive 4 degrees Celsius can be written without the positive sign. Negative 18 degrees Celsius means it is 18 degrees colder than the freezing point of water. It is 18 degrees Celsius below 0 degrees Celsius. 4 degrees Celsius means it is 4 degrees warmer than the freezing point of water. It is 4 degrees Celsius above 0 degrees Celsius. The group of all the negative whole numbers, positive whole numbers, and 0 are called integers. Any decimal numbers or fractions are non-integers. Hence, integers do not include any decimal numbers or fractions.
Activity 1. Question number 1. From the following, which numbers are integers? 1.6, 2, 90, 0.5, negative 200, negative 3.4. Yes, you got it all correct, isn't it? The correct answer is 2, 90 and negative 200. As you all know, 1.6, 0.5 and negative 3.4 are decimals, and decimals are not integers. Question number 2. On a number line, where does the positive integers are? Is it to the left of 0 or to the right of 0? Well, what do you think the answer is? Yes, you are absolutely correct. Positive numbers are to the right side of 0. Question number 3. The diagram shows a thermometer. It shows that the temperature is 18 degrees Celsius above the freezing point, 18 degrees Celsius below the freezing point, or is it exactly the same as the freezing point? Yes, the answer is 18 degrees Celsius below the freezing point. As you all can see, it shows that the temperature is negative 18 degrees Celsius. Well done. Now give yourself a clap for doing this work.
Alright, let's learn how to compare and order integers. In maths, comparing means saying which number is bigger and which number is smaller than the other or equal to each other. Ordering means arranging numbers into their correct place following some rule. And in ordering integers, you must know what is an ascending and descending order is. Ascending order, that will be arranging from the smallest to the largest, and in descending order it is largest to smallest. Well, let's go back to the number line. Do you know that there is no happier number than 0? Because when you had to compare 0 when you were in preschool or in elementary school, pretty much every time when you were asked to compare numbers, 0 was always the smallest number, right? But not today. Let's look at the number line. You can see 0 is larger than any number left side on a number line, right? Therefore, 0 is larger than any negative number. Now, let's try this together. Let's put these integers in order. Let's order from the smallest integer to the biggest. The larger the negative value, the smaller the number will be. The farther you go to the left side of the number line, the smaller the number will be. So, in this case, how you will write these numbers in ascending order?
Let's order these numbers in ascending and descending order. Let's try out the first one. In here, it's asked to arrange the numbers in ascending order, right? What do you think the arrangement will be? Yes, you're absolutely correct. From these numbers, the smallest will be negative 12, then negative 9, negative 2, 0, 3, and positive 7 will be the largest. How about this one? In this question, it's asked to arrange in descending order. Try it. That's good. The largest will be 4, then 0, negative 2, negative 7, and the smallest will be negative 15. Give yourself a clap now as you have done it correctly.
Alright, now let's learn how to compare integers by using these symbols. Do you remember these symbols? The arrow always pointing to the smaller number and eating the larger number. There is something that you have been studying in primary grades, which is actually a funny way to remember this, right?
Now let's sing all the Alligator song to recall about these signs.
There was an alligator living in the swamp who'd sneak up on numbers and start to chomp. Whenever two numbers sat on the ground, she'd face the bigger one and gobble it down. When there are two numbers that are the same, the gator changes form and she swaps her name. Because she isn't sure exactly how to dine, she stands right in the middle as an equal sign. Number gators like to eat what's greater. They turn their backs on what is less. Their mouths open wide for the bigger side, and they munch down the whole great mess.
Do you know there is another way that we can use the signs? Let's see.
Math signs are quicker, tidier, and they're recognised around the world. Have you seen this before? This sign means greater than. We use it to show that one value is greater than another. So we could write 4 is greater than 2. We know this statement is true. 4 is more than 2. This sign faces the opposite way. It is the less than sign. We could use it to write 5 is less than 10. Right about now, you might be thinking, how can I tell those signs apart? I'll explain the sign and you're going to get it very quickly. We understand the sign from left side to right side, like reading a word on a page. On the left, I see 2 points, and on the right, there's 1 point. 2 is greater than 1. This is the greater than sign. I'll use it again. 6 is greater than 3. This sign faces the other way. Again, go left to right. On the left, there's 1 point, and on the right, there are 2 points. 1 is less than 2. This is the less than sign. Here's another example. 5 is less than 10. You can use this thinking to get it right every single time. What's this? Which sign do we use with these numbers? Well, put 2 points beside the bigger number and 1 beside the smaller number. Join the dots and we've instantly got the correct sign. This statement reads 2 is less than 8. Another one. Put 2 points beside the bigger number, 1 beside the smaller number. Join the dots. This statement reads 11 is greater than 7. You can see writing the sign is easy. Reading it off takes a bit more practice. In time, these new signs will become familiar, just like these signs.
This is the number line. We have 0 in the middle, positive integers on the right, and negative integers on the left. When we move towards the right on a number line, the numbers keep increasing. And as we move towards the left, the numbers keep decreasing. Consider any random number, say 2. Now choose any number to its right. Say 5. 5 is greater than 2. Now choose another number, say 4. Even 4 is greater than 2. If we choose a number to the left of 2, say 1, we can see that 1 is less than 2. Suppose we choose -3. -3 is also less than 2. Here's a very basic thing to remember. Right means larger and left means smaller. And this helps us understand a simple concept. Every positive integer is greater than any negative integer. It's because all positive integers are to the right of any and every negative integer.
If your teacher gives you a pair of numbers like this, then you use a sign you already know. Now, it's time for you to use the greater than and less than signs for yourself in your math book. And while you're practicing, you'll be building your math muscle.
Let's try to compare these integers by using these symbols.
Okay, let's try the first one. You have got positive 13 and positive 9. In positive integers, it's very easy. As you all know, 13 is larger than 9, right? Therefore, the pointer will be facing towards the smaller number, which is 9. Next one. You have got positive 17 and negative 11. So, which number will be smaller in this case? Yes, you are right. It is negative 11 because negative integers will be always smaller than the positive integers. Therefore, the pointer will be facing to the negative 11 and positive 17 will be greater. And see, the symbol is eating positive 17, right? Let's try this one. What do you all think, which number will be smaller in this case? Or farther in the number line from 0? Yes, you are right. It is negative 16. Therefore, the pointer will be facing to the negative 16 and negative 13 will be larger. Well, let's try the last one. In this question, you have got negative 3 and a 0. So what do you think, which integer will be bigger in this case? You are absolutely correct. It's 0. Always remember 0 will be bigger than any negative numbers. So the pointer will be facing to negative 3.
Positive numbers will be always greater than the negative numbers. 0 will be always greater than any negative numbers. So that's the way you compare and order integers. Alright, let's reflect what we have learned in today's lesson. We have learned what integers are and how they can be used to describe things in the real world and how to order and compare them. Sometimes comparing and ordering might be a little tricky and confusing at first. So make sure you practice until you really get it, because practice makes perfect. Thank you all for attending this maths class. Hope you all enjoyed today's lesson. That's all for today. Take care and be safe. Bye bye.